Let's look at solving augmented argument trigonometric equations. So these are things where we change the argument. So for example, we might be finding sine of 3 theta or cosine of theta divided by 2, or things like tan of theta plus 45, or sine of theta minus 36, or things like this. Anything where the argument is not just a single value. So here we have our first example. We've got here 3 lots of theta. Now, we are used to solving equations where the argument is just a single character, so let's do that. Let's make it back to being a single character. I'm going to call that character x. So in place of 3 theta, I'm going to write x. So this becomes 2 sine of x is equal to square root of 3. Or sine of x is equal to root 3 over 2. And I know that my principal solution from this is going to be 60 degrees. Now I'm dealing with 3 theta, so the range is also going to change slightly when I'm thinking about x. So I need to multiply these by 3, which is going to give me 160. So what I want to do is I want to solve this equation over the range x is between 0 and 360. Well, I know my principal solution is 60 degrees, so let's draw that on our unit circle. I'm talking about sine, so I want to go through this axis and down. So my second solution would be here at 120 degrees. My next solution is going to be at 360 plus 60 degrees, which is 420. But 420 is out of range because I know I only need to go as high as 360. So there are my solutions. X, which we know is 3 theta, is 60 degrees or 120 degrees. Now, simply, if I want to find out what theta is, I just divide these values by 3. So theta will turn out to be 20, or theta will turn out to be 40. Let's see that again. This time I'm dealing with cosine of 2 theta. So again, I don't want to deal with 2 theta, so let's get rid of 2 theta and replace it with an x, where x is 2 theta. So this becomes solve 2 cosine of x plus 1 equals 0. Solving that, I get cosine of x is equal to minus a half, so x is going to be 120 degrees. Now this time, again, need to change my interval, so I'm talking about 2 theta, which is 720, and in here 0. So I'm solving this on the range where x is between 0 and 720. Let's map these things out. So on my graph, I'm going to draw on 120 degrees. And my other solution, this is cosine this time, is going to be down here at 240 degrees. Now, this time my range is 0 less than x less than 720. So 240, I wrap round back to 360, and another 120 would take me to a further solution of 480, and another 120 would take me to a further solution of 600, and then I end up back here at 720. So this equation has 4 solutions. X, which was 2 theta, is 120, 240, 480, and 600. So theta, if I divide by 2, is going to be 60, 120, 240, and 300. It's exactly the same when we augment by addition or subtraction. I don't like solving these things, so I say let x become theta minus 30. Then what I'm trying to solve is that tan of x is equal to 3, or that tan of x is equal to 3/4, and again here my principal solution comes out to be 36.9. Again, I need to change my range, so I'm subtracting 30, so I want to solve between 150 degrees and minus 210 degrees. So on my diagram, I draw on 36.9, and I know that for tan I just extend backwards, and by further solution 36.9 I would have to add on 180 to get to this solution. Well, that's going to take me out of range, because I know that my range for this stops at 150, so I can just leave that solution. The other one would be going back 180 degrees, so 36 subtract 180, and that's going to give me negative 143.1. So there are my solutions. X, which is theta, there we go, x, which is theta minus 30, is minus 143.1 or 36.9. Correct that. And again, to get to theta this time, I need to add on 30 degrees. So adding 30 degrees onto this is going to give me minus 113.1, and adding 30 degrees onto this one is going to give me 66.9. And those are my solutions for that equation. So always the trick that we're doing here is to take whatever the argument is and replace it with x. Do the simple solve, find multiple solutions, and then solve a little equation to find our original theta.